This video will help you understand the security activities that your software development teams and/or software vendors should use to reduce vulnerabilities in the software they develop, and supplements the simplified implementation of the SDL white paper published by Microsoft. Microsoft already has a wealth of experience in creating secure applications and operating systems for mobile devices, tablet PCs, servers, desktop PCs, the web, and the cloud. One of the most important factors that leads to Microsoft creating secure software is the use of the Security Development Lifecycle, or SDL, in almost all projects. You can check the SDL website for a collection of recent case studies. These studies highlight how the SDL has been used in the development of Windows 7, Microsoft Office, Windows Internet Explorer 8, ASP.NET MVC, Windows Server 2008, and many more products. So what is the SDL? The SDL is a set of processes and tools designed to minimize the number and potential impact of any security vulnerabilities in a software product. These processes and tools are used at every stage of the software development lifecycle, beginning with security training for all team members. During the requirements phase, the team will identify the key security objectives for the product, set the appropriate bug bars that define security and quality for the product lifecycle, and perform security and privacy risk assessments. During the design phase, the team will undertake a threat modeling exercise to analyze and document the application's attack surface. During the implementation phase, the development team will take steps to ensure that the code does not contain any known security vulnerabilities. The team will use several techniques, performing static code analysis and enforcing banned functions. During the verification phase, the team will use various testing techniques, such as fuzz testing and reviewing the attack surface to verify and deal with known vulnerabilities. Threat modeling and attack surface analysis from the design phase should be used here, together with documentation from the implementation phase, to ensure the continuity of risk management across the product lifecycle. In the release phase, the final security review is completed to ensure that the application is secure enough to ship. Additionally, if you do not have one in place, an incident response plan should be built to assist ongoing security support for the product or application. Finally, during the response phase, the product development team must be available to deal with any possible security vulnerabilities or privacy issues that warrant a response. This means that the response team has access to all of the artifacts created during the product lifecycle. This includes threat modeling documents, bug bars, any bugs that were delayed or not fixed, and any other data necessary to perform post-release servicing tasks. The first phase of the SDL that an organization should implement is the training phase. During this phase, all members of the software development team must receive appropriate training to stay informed about security basics and recent trends in security and privacy. Individuals in technical roles who are directly involved with the development of software programs must attend at least one unique security training class each year. Basic software security training should cover foundational concepts such as secure design, threat modeling, secure coding, security testing, and privacy. This basic training establishes an adequate knowledge baseline for technical personnel. As time and resources permit, training in advanced concepts may be necessary. Following the training phase, the requirements phase is where development teams identify key security objectives and consider how to integrate security and privacy into the development process, while minimizing disruption to application usability, plans, and schedules. The SDL includes general criteria and job descriptions for security and privacy roles. The important roles are the security advisor and privacy advisor roles, which are typically filled by subject matter experts from outside the project team. The people chosen must possess verifiable subject matter expertise in security. They must monitor each phase of the software development process and attest to successful completion of each security requirement. These roles may be combined if an individual with the appropriate skills and experience can be identified. After roles have been assigned, minimum security requirements are specified for the application as designed to run in the production environment. Finally, a bug or work item tracking system is specified and deployed. Quality gates and bug bars are then defined to establish minimum acceptable levels of security and privacy. Your project team must negotiate quality gates for each development phase and then have them approved by the security advisor. An example quality gate is that all compiler warnings must be triaged and fixed prior to code check-in. A bug bar is a quality gate that applies to the entire software development project and is used to define the severity thresholds of security vulnerabilities. For example, the specification that there should not be any known vulnerabilities with a critical rating in the application at the time of its release. After the bug bar has been set, it should never be relaxed, even as a project's release date nears. Finally, security and privacy risk assessments are performed, which identify functional aspects of the software that require deep review. A privacy impact rating is then identified for the feature, product, or service as required. A high privacy risk means that personally identifiable information is stored or transmitted, settings or file type associations are changed, or software is installed. A moderate privacy risk means that the sole behavior that affects privacy is a one-time, user-initiated, anonymous data transfer, such as the user clicking a link and the software loading a website. A low privacy risk means that no behaviors exist that affect privacy. After the requirements phase, the design phase identifies the overall requirements and structure for the software and establishes design best practices. The first step is to establish the design requirements. These should describe security or privacy features that will be directly exposed to users. Additionally, all design specifications should describe how to securely implement all functionality provided by a given feature or function. After the design requirements are established, they should be reviewed by the security advisor and privacy advisor if appropriate. Attack surface analysis is then performed as a means of reducing risk by giving attackers less opportunity to exploit a potential weak spot or vulnerability. This analysis includes attack surface reduction, which encompasses shutting off or restricting access to system services, applying the principle of least privilege, and employing layered defenses wherever possible. Finally, threat modeling is undertaken. Threat modeling is a team exercise that enables the development team to consider, document, and discuss the security implications of designs in the context of the production environment. Threat modeling can be undertaken using a variety of methods. However, the preferred method is the use of the SDL threat modeling tool, which is based on the STRIDE threat classification taxonomy. During the implementation phase, the development team follows best practices to ensure that the code does not contain any known security vulnerabilities. First, the development team publishes a list of approved tools and their associated security checks, such as compiler and linker options, warnings, and code check-in requirements. This list should be approved by the security advisor for the project. Additionally, development teams should always strive to use the latest version of approved tools to take advantage of new security analysis functionality and protections. Next, the project team should analyze all functions and APIs that will be used in the software development project and prohibit those that are determined to be unsafe. Ban.h, provided by the SDL team, is effective in helping you to meet this requirement. After the banned list is determined, project teams should use code scanning tools to check code for the existence of banned functions and replace those banned functions with safer alternatives. Static analysis of source code is then performed to help ensure that secure coding policies are being followed. FXComp can be used for static analysis of managed code, and certain editions of Microsoft Visual Studio feature integrated tooling that can be used for static analysis of unmanaged code. Static code analysis by itself is generally insufficient to replace a manual code review. Therefore, a manual code review may be performed as an optional task in the SDL, often by the security advisor. A manual code review is usually focused on the critical components of an application, such as where sensitive data is processed or stored. The verification phase is the point at which the software is functionally complete and is tested against security and privacy goals outlined in the requirements and design phases. Threat modeling and attack surface analysis from the design phase should be used here, together with documentation from the implementation phase to ensure the continuity of risk management across the product lifecycle. Dynamic program analysis is performed by using tools that monitor application behavior for memory corruption, user privilege issues, and other critical security problems. This analysis ensures that a program's functionality works as designed. Runtime tools like App Verifier can be used, along with other techniques such as fuzz testing. Fuzz testing is used to induce program failure by deliberately introducing malformed or random data to your application. The fuzz testing strategy is derived from the intended use of the application and the functional and design specifications for the application. The mini-fuzz file fuzzer, provided by the SDL team, is effective in helping you to meet this requirement. It is critical to review threat models and the attack surface measurement of your application when it is code complete, because it is common for an application to deviate significantly from the functional and design specifications created during the requirements and design phases. This review ensures accountability for any design or implementation changes to the system. It also ensures that any new attack vectors created as a result of the changes have been reviewed and mitigated. Penetration testing can be optionally applied to attempt to uncover potential vulnerabilities resulting from coding errors, system configuration faults, or other operational deployment weaknesses. During the release phase, the project team creates the incident response plan, performs the final security review, and archives all pertinent data for post-release servicing of the software. Every product or service developed using the SDL process must include an incident response plan. The incident response plan should include staff to act as points of first contact in a security emergency, on-call contacts with decision-making authority, who are available 24 hours a day, 7 days a week, and security servicing plans. The final security review then takes place. It helps to determine whether the software is secure enough to ship by examining the security activities performed on the software application. This review is carried out by the security advisor with assistance from the regular development staff. The review includes an examination of threat models, exception requests, tool output, and performance against the previously determined quality gates or bug bars. The end result in one of 3 different outcomes: passed, passed with exceptions that are logged and corrected in the next release, or failed. Finally, all relevant information and data must be archived to allow for post-release servicing of the software. This includes all specifications, source code, binaries, threat models, documentation, emergency response plans, and any other data necessary to perform post-release servicing tasks. After a software program is released, the product development team must be available to deal with any possible security vulnerabilities or privacy issues that warrant a response, using the plans and resources that were developed during the release phase. All security vulnerabilities identified during the development of a product should be analyzed and taken into consideration when building training and requirements for the next version of the product. Why should an organization care about implementing the SDL? First, the SDL can be applied by any software development organization, regardless of its size or the platform or development methodologies that it uses. The SDL is versatile enough to allow for the addition of other policies and techniques, creating a software development process that is unique to an organization. Second, the National Institute of Standards and Technology estimates that code fixes performed after release can result in 30 times the cost of fixes performed during the design phase. By following a defined process like the SDL, which systematically addresses software security during the development phase, vulnerabilities are more likely to be found and fixed prior to application deployment, reducing your total cost of software development. Finally, the SDL helps you to write more secure code by reducing the number and severity of vulnerabilities in your code. Security experts analyzed public vulnerability counts in pre-SDL and post-SDL versions of the same product in the 12 months or more following the release, and discovered there were up to 91% fewer vulnerabilities in some products. The Microsoft SDL is a freely available process for improving software security and privacy. It has been applied to hundreds of software programs and hundreds of millions of lines of production code. The SDL consists of mandatory actions that follow the traditional software development process, but it is flexible enough to allow for the addition of other policies and techniques. This creates a software development methodology that is unique to your organization. The combination of process, training, and tools produces distinct benefits, such as increased predictability, technical competence, and more secure software, which translates into lower risk for both your organization and the software user. For further information, or to find many of the tools that were mentioned, such as FXComp, Band.h, and the MSF Agile Plus SDL template, take a look at these websites.